So what are we going to cover in the rest of, I'm working now. I don't have to talk so loud. Yay. So what are we going to cover in the rest of the presentation? Well, the rest of the presentation is going to be about the basics of IPv6 and IPv6 addressing methods, how to configure IPv6 on Linux, and how to deal with IPv6 if you don't have IPv6 from your ISP just yet. Step 1, call your ISP and complain. Okay, and we'll talk about how to get IPv6 for free because it is, after all, a free conference. IPv4 versus IPv6. You've all probably heard this by now. 32 bits versus 128 does not mean 4 times the address space. It means 4 billion times 4 billion times 4 billion times as much address space. The total address space usable in IPv4 was 3.7 billion addresses. The usable unicast address space in IPv6 is 42 undecillion and then some, give or take an undecillion, or a few hundred quadrillion. The most prevalent network size in IPv4 was the /24, 254 host addresses. The most prevalent network subnet size in IPv6 is the /64. Anybody want to take a guess at how many hosts you can put on a /64? I'm looking for a 3-word answer. A bunch is 2 words, but it's a good try. All of them. I heard somebody say all of them in the back. Yes, sir. If that's 18 quintillion, then yeah, that works too, but that's a fancy way to get to. The bottom line is you can put as many hosts as you ever care to. You're going to run out of switch neighbor table adjacency space before you run out of host space in an IPv6/64 subnet. So the convenient answer is, how many hosts can you put in a 64? All of them. Okay. Notation, in IPv4 we use dotted decimal quads to represent 8 bits per quad or per octet. Hexadecimal quads in IPv6, 4 hex digits per quad, 8 quads, gives us 128 bits, 16 bits per quad, 4 bits per digit. Much more compact than it would be if we tried to write it out in decimal. In terms of shortening, in IPv4 we could suppress the leading zeros in each octet. In IPv6 we can not only suppress the leading zeros in each quartet, but we can also take any single consecutive group of zeros and compress it to a double colon. So let's talk about how to compare the address space, because it's very hard for people to visualize 18 quintillion, let alone 340 undecillion. So if we think about each host as being an almond M&M, a large packet of almond M&Ms has roughly 254 M&Ms in it. Yes, I did count a couple of packets of M&Ms. However, I used math for the rest. So if you were to take the entire IPv4 address space as /24s and use a single M&M to represent each /24, you'd have enough M&Ms to roughly cover 70 yards of an American football field. I say that specifically because I speak at international conferences and soccer pitches are much larger. It wouldn't even cover half of a soccer pitch. Okay? On the other hand, in IPv6, a single /64 contains enough host addresses to fill the Great Lakes with M&Ms. All of the Great Lakes completely full. We also have enough /64s that if you represent each 64 with an M&M, you can again fill the Great Lakes with M&Ms. So this means that you have the Great Lakes full of M&Ms squared worth of addresses. Okay? So completely fill the Great Lakes with M&Ms, and then for every M&M in the Great Lakes, fill the Great Lakes with M&Ms again. That's the IPv6 address space. The lawyers have told me that I do have to tell you, please do not attempt to eat a /64 worth of M&Ms of any type, as adverse health consequences can occur. Okay, so this requires us to think a little bit differently about this. In terms of IPv4 dogma, we thought in terms of hosts. How many hosts do I need to put on this network? I need 6 hosts. Well, I have to give that a /29. I need 7 hosts. Damn, I have to give it a 28, but I really hate to waste all those addresses. That's 6 extra addresses I'm wasting. In terms of IPv6, we don't count hosts. We give each subnet a /64, and it doesn't matter how many hosts we're putting on it. They all fit. If we have growth, it still fits. If we have more growth, That still fits too, right? That means we can change our way that we optimize our addresses. In IPv4, we were concerned about scarcity first and aggregation second. That's why we have a 400 plus thousand routing table in the interdomain routing space in IPv4. And it's only going to get worse, okay? In IPv6, we can focus on aggregation, at least for this first 1/8 of the IPv6 address space that we're currently allocating from, of which we've allocated less than 1/512. Okay. The address issued methodology in IPv4 was hand it out slow in small chunks and make them bigger as you have to over time and add more chunks where you have to. In IPv6, we're trying it a little bit differently. We're cutting things in half, handing out big chunks up front, and hoping that people don't have to come back for more chunks very often, and that we can keep the size of the routing table down as a result. In IPv4, we didn't have enough addresses, so we started having to do interesting and damaging things to the protocol, NAT, in order to make everything fit. In IPv6, there is no need for NAT. For those of you who are thinking NAT is a security device, NAT is actually an anti-security device. I will happily talk to you after the presentation, if you want, about how NAT damages your security rather than helping it. Okay. In terms of address configuration, it's pretty much the same. In IPv4, we had static and DHCP. In IPv6, we have static and DHCP, and another address configuration method that's a lot lower overhead called stateless address auto-configuration. More about that later. Okay? You've all seen this image by now, I'm sure. We have a new concept in v6 called address scopes. Okay, there are two defined scopes currently, link local and global. There used to be a site local scope, but it was deprecated in favor of what they call unique local addresses, which operate very similar to RFC 1918, but with a lot less potential for collision. The link local address is only valid on a given link. A link is defined as everything you can reach from one network interface without going across a router. Okay. Link locals all start with FE80. Technically, it's a /10, but it's supposed to be FE80 followed by the remaining 54 bits being all 0. So even though it's a /10, it might as well be a /64. And then it's followed by a 64-bit interface ID. Link local is present on every IPv6 capable interface in the system, including loopback. Okay? Your loopback interface will have a link local address. Every Ethernet interface participating in IPv6 will have a link local address, etc. If an interface does not have a link local address, it cannot run v6. Therefore, since they all have the same prefix, when you want to reach a remote machine via its link local address, you have to tell the system which interface you want to send the packet out through. This is done by usually by appending a % at the end of the address, followed by the interface name, or in the case of Windows, a random number representing the interface through some internal Windows process that nobody understands. Unique local addresses, much like RFC 1918, global is what you're used to dealing with today. Any address on the internet is a global scoped address. Global unicast in IPv6 is currently being allocated from 2000:/3. Stateless auto configuration, the easiest way to configure an IPv6 address. Turn the interface on, it gets an address. Thank you very much. Okay. It provides only prefix and router information. It does not provide services addresses, though there is now a protocol for enabling DNS server information called RDNSS, recursive DNS servers available in Slack, so you can actually now provide DNS servers. Not all routers and devices have implemented RDNSS yet, unfortunately. And it does have the unfortunate habit of assuming that every router advertising router advertisements is a candidate default router and will forward your packets wherever you're sending them. There's no real provision for doing more granular routing. Stateless autoconf uses the MAC address to produce a link local address, FE80 : MAC address converted to 64 bits. If you're starting with a 48-bit MAC address, it's very easy to convert to 64 bits. You spread it apart into two groups of 24 bits, place FFFE in the middle, and you now have 64 bits. But now, because it's no longer a globally assigned 64-bit MAC address, you have to invert the 2-bit of the first octet in order to mark it as a locally assigned MAC address. This is well documented in the IEEE standards. Next thing you do is you do a duplicate detection. Is anybody using my address? And if somebody says, yeah, that's me, you shut down IPv6 on the interface and you are done. Okay? This is as opposed to the IPv4 process where duplicate address detection was, oh, look, somebody else sent a packet with my address. How cute. Duplicate, duplicate, duplicate in the log messages, and everything breaks, and both systems have trouble working. In IPv6, we figure Johnny-come-lately shuts down the interface and says, this isn't going to work, and the other system keeps working. More deterministic, easier to troubleshoot, and the one that was already there keeps working. It's the one trying to attach to the network that still has a problem. Once we've got IPv6 up and running on the interface with Link Local, we send out a router solicitation message to the All Routers Multicast group. Then all of the routers respond with an ICMP6 router advertisement, and hopefully that will also contain the local prefixes and whatnot, and we can configure our global address by taking the local prefixes, adding our UI64 address to that, and voila, we've got a global address. Any questions on stateless autoconf before I move on to DHCP? Yes? Yes. Yes. Everything should always be a 64 anyway. You do have the option of doing other things, but it's generally a really bad idea to do so in IPv6. The question was, is stateless autoconf always a /64? And the answer is yes, but so should everything else be in IPv6. There's nothing in the protocol that prohibits you from using other prefix sizes, but it's generally a bad idea, and you're going to cause yourself pain with no benefit if you do so. DHCP-v6 can support other prefix lengths besides just /64. Ideally, this is used for prefix delegation, where, for example, your ISP might have your home gateway a /48 for your home gateway to carve up among its interfaces and or other downstream routers within your house. So, for example, if you've got an entertainment system that has a router front-ending the entertainment system, it might delegate a /56 to that, and it might delegate another /56 to the router that separates your guest wireless from your internal wireless, et cetera, et cetera. It can assign addresses to hosts, but it cannot provide default router or any other router information. You cannot do router information in DHCP-v6 currently, unlike DHCP-v4. So be aware of that. You're going to have to get your router information either from a routing protocol or from a router advertisement. It can provide additional information about DNS servers, NTP servers, boot file names, et cetera, et cetera. All of those options from DHCP-v4 do exist in DHCP-v6. There's still a pretty strong lack of vendor support for DHCP-6, though Apple is finally on board as of Lion, and Mountain Lion has even improved DHCP-6 support. Mountain Lion is the first version to have RDNS support for Slack. Any questions on DHCP before we move on to static? One nice thing about DHCP-6, the DHCP relay configuration is much cleaner and much more straightforward. And the DHCP protocol was designed with the concept of DHCP relays built into the protocol. Static addressing. IPv6 can be assigned statically, just like IPv4. It's very common to use one of two techniques, prefix : address, where the address is the binary conversion of the previous IPv4 address into hex, or IPv4 prefix : address, where address is expressed as the binary coded decimal equivalent of some of the last octets of the IPv4 address. As long as your first 12 bits of your IPv6 suffix are 0, that is : 000 and then whatever, you'll be fine. You won't conflict with any of the stateless autoconf addressing ranges. You should also set your DHCP ranges up in accordance with that limitation. Privacy addresses. Any questions on static addressing? Bueller? Okay. Privacy addresses. These are essentially a pathological form of stateless autoconf. They are only supposed to be used for outgoing connections. Your incoming stuff should still come to your EUI64 or statically assigned addresses. But basically, you generate a random 64-bit suffix using an MD5 hash and some other components instead of generating an EUI64-based prefix. These are for privacy concerns. People didn't want to have their MAC address tracked as it went to different coffee shops. I can kind of understand that. Mostly these create more problems than they solve. They're documented in RFC 3041. And the preferred and valid lifetimes for the MD5 hashes are derived from the stateless autoconf addresses. These are now the default in Lion and Vista and later operating systems. Any questions on those? They're not the default in Linux yet, by the way. Yes? There is, and you can turn them off in Windows and Mac OS, just like you can turn them on in Linux. Multiple addresses per interface. In IPv4, this was kind of unusual, although it's become more common. And IPv4 does have some support for it in most implementations. ETH0 : whatever in Linux, for example. IPv6 has full support for this in all implementations. In fact, it is very unusual that you could have a useful IPv6 deployment that doesn't have at least 2 addresses on every interface, right? Because you have to have a link local address, and if you want to talk to the world, you have to have a global address. So you're going to have at least those 2 on most interfaces. IPsec. In Linux, IPsec is a lot cleaner than IPv4. In IPv4, it was actually backported from IPv6 and sort of added on to IPv4 as an afterthought. In IPv6, it was built in from the ground up. It does not require IPsec utilization, but until very recently it was a required. It is now an optional part of IPv6 stack. It's a lot easier to configure IPsec in IPv6, and it's a lot easier to debug as well. In fact, so much so that IPv6 will support opportunistic encryption on links in some future versions. Microsoft has a product called Direct Connect or something like that actually already is IPv6 opportunistic IPsec encryption. Direct access, that's it. I don't keep up with Microsoft, so it's been 10 years since the last time I touched a Microsoft product. Configuring IPv6, thank you. I'm happier for it too. Configuring IPv6 native on Linux. The interface configuration depends on your distro. Debian-based distros use Etsy network interfaces or Etsy interfaces. Red Hat distros, Red Hat, CentOS, Fedora, etc., use Etsy sysconfig network scripts ifcfg-name. Etsy network interfaces looks like this. Very straightforward. You can see the IPv4 configuration at the top, the very simple IPv6 static configuration in the middle, and the incredibly complex IPv6 autoconf at the bottom. iFace ETH1 INET6 auto. Slack. Not just for breakfast anymore. Okay, Etsy sysconfig network scripts looks a little bit more complicated, but it's actually pretty straightforward, and once you get used to working with it, I find it easier to work with than Etsy network interfaces myself. But the IPv6 adder secondaries is an unfortunate artifact of, I suspect, whoever named the variables in the config file used to work with Cisco products a lot. There is no concept of secondary addresses in IPv6. All addresses on an interface are created equal. In Linux, you don't have, whereas you have ETH0 : 1 : 2 : 3, etc. for IPv4, you don't do that in IPv6. All of the IPv6 addresses are added to the root interface. And the interface itself supports multiple addresses. And it does it through these secondaries configuration lines. And then, of course, we have the autoconf at the bottom again IPv6 init equals yes, autoconf equals yes. Again, very complex auto configuration there. So without a native configuration, what does that mean? Well, if you don't have an ISP that supports IPv6, and unfortunately many of you don't, how many people here have IPv6 from their home ISP native today? 2 hands. That's better than last year. Yeah. Okay. And you? Okay, good to know. Comcast is starting doing native IPv6 for some of their subscribers as well, and AT&T has actually got 1% of their subscribers rolled out at this point. So hopefully we'll see more of that over the course of the year. Your options are 6in4, which is a lot like GRE. It's just a straight statically configured manual tunnel. That's usually your best option. If you can't do that, 624 is an automatic tunnel using some Anycast magic, and we'll talk more about that in a little bit. And if you can't make that work because you're stuck behind a firewall and you can only get UDP and TCP in and out through NAT, well, you might have to resort to Teredo, a protocol that even Microsoft refers to as should be your absolute last resort. And when you consider that Microsoft is saying that about their own product, Teredo being a Microsoft product, you know, if Microsoft's willing to admit it's that bad, it must be pretty bad. The nice thing about 6in4, most network administrators are pretty familiar with GRE, and they understand static tunnels. Really, the only 2 differences between GRE and 6in4 is there's a different protocol number. GRE uses 45, and 6in4 uses 41. And GRE can transport both IPv4 and IPv6 through the tunnel, whereas 6in4 can only transport IPv6 through the tunnel, and it can only be an IPv4 outer encapsulation. GRE, the outside encapsulation can be IPv6, IPv4, IPX, or whatever, and the inside encapsulation can be anything as well. So it's kind of an anything inside anything protocol. It's simple, it's deterministic, there's no Anycast magic, so it's easy to debug. It's controlled by 2 endpoint administrators, or possibly 1, which greatly simplifies debugging. You get Ernie at the other end on the phone, and you say, hey, Ernie, I'm seeing this. When I pump this packet in, what do you see come out the other end? And Ernie says, it's not getting here, and then you know where you got to debug it, right? Or Ernie says, well, I got this out. What do you see when I put this in? And you can troubleshoot it pretty quickly that way. The disadvantage, you actually have to configure it manually, but it's really pretty easy to configure. So why would you want to use 6to4? Well, if for some reason you can't make 6in4 work, or perhaps your host moves around a lot, maybe it's a laptop or a cellular phone, maybe you want a tunneling solution that doesn't require you to reconfigure everything at both ends every time you change the address of one end. In which case you might want 6to4. When it works, it's pretty clean and relatively self-optimizing. It's very hard to troubleshoot when it doesn't work because it is absolutely not deterministic in either direction. What does that mean? It means your test packet may follow this route to this 6to4 server, and then this route across the IPv6 network, and your next packet may follow this other route to this completely different 6to4 server, and then this other route through the IPv6 network, and there's no way to force either one of them to behave consistently long enough to troubleshoot anything. Okay? It mostly will behave consistently because Anycast mostly works until route churn occurs, pretty much the same way. However, if you happen to have something in between that's doing a lot of route churn, your 6to4 tunnel is going to go poof, and you're going to have a really, really entertaining time trying to find out why. Teredo, all of the joys of 6to4, all the same Anycast problems with some additional Microsoft magic thrown in. Now, what's really cool about Teredo is it doesn't use any sort of generic packet. It uses a UDP packet. And so it will go through firewalls very nicely. It looks like an outbound UDP session to the firewall with inbound replies. Unfortunately, once that first packet goes out, it's not an inbound reply. It's an inbound wide open IPv6 bidirectional route, completely stateless. And it's going right through your firewall whether you know it or not. So If you're running an IPv4 firewall and you're not IPv6 aware, you're probably running an IPv6 non-firewall without knowing it for all those Teredo users on your network. It is enabled by default in Windows, whether you want it or not, though it does not turn itself on until somebody tries to do something over IPv6. Moreto is available if you want to implement this on Linux, both client and server. It's very complicated and tricky to debug, even more so than 6.4. But it does actually work in many circumstances where the others do not because of its ability to penetrate NAT and firewalls. So if you actually want it to do that, it's a very good thing. If you're actually counting on your NAT firewall for security, it pretty much eliminates that. IPv6 for free, yes, you can get IPv6 for free. There are a number of tunnel brokers that offer free IPv6 tunnels of various forms. My favorite is the 6-in-4 tunnels offered by the Hurricane Electric Tunnel Broker. Admittedly, I may be a little bit biased on that. Though I will say the reason I'm working for Hurricane Electric is I like what they're doing with V6 rather than the other way around. If your organization has a presence at an exchange point where Hurricane Electric is also present, we are happy to peer with you and provide free IPv6 transit. Okay. Any questions on any of that before I move on to routing? Yes? I'm not understanding the question. I'm sorry. You can do Yes, both ends have an IPv4 address, and you tunnel IPv6 through IPv4 from one end to the other of the tunnel. No. Yeah, I'm Yeah, use multicast for that. That's what it's intended for. Yeah. If you're trying to load balance your routes across two different tunnels, we do offer BGP tunnels. And so you could do two BGP tunnels and run the same IPv6 address across two different BGP tunnels. So you can load balance across two tunnels that way if you want. Okay, routing. The usual suspects, OSPF, the V6 version is OSPF v3. BGP4 still works for V6. It's just address family INET 6. And we have router advertisements, and the unfortunately named router advertisement daemon in Linux is radvd. There is also support for IPv6 in Quagga and most of the other open source routing platforms. In terms of firewalls, IP6 tables, much like IP tables, just hexadecimal larger addresses. This is an actual excerpt from my actual IP6 tables file, so I know that these things really do work. I'm running it at home. In terms of DNS, forward DNS, just add quad A. Just like IPv4 A records, quad A records are virtually identical except it's an IPv6 address on the right-hand side. Reverse DNS, a little bit more complicated. Instead of inaddr.arpa, it's IP6.arpa, and we have to put all the zeros back before you then reverse the address, then take out all the colons, replace it with dots, or put dots in all the middle, in between every digit, rather. So every hex digit is a zone boundary in the IP6 reverse DNS, which means we don't have to worry about pesky weird hacks to deal with CNAME records pointing to PTR domains that don't exist. Yeah. So we can actually delegate a /28 very easily in IPv6, and since that's on a 4-bit boundary, it lines up nicely, and you go from there. And if you have to delegate 8, 4, 2, or 1 zones, out of an IPv6 quartet, or even all 16 of them, it's not a big deal to have 16 sets of NS records pointing at the same server instead of having to do weird CNAME things. So that's actually quite nice. Bind versions ship with IPv6 template zones, hence RFC 1912, etc., and have for a long time now. IPv6 addresses are valid in all of the ACLs, etc., with all of the same semantics as IPv4. Zone configuration is identical, except the reverse ranges have to be called IP6.ARPA instead of inaddr.ARPA. You can see that is a named.conf excerpt for the reverse zone for my /48 at my house. And yes, that you can ping things in that 48. It really exists. $origin is your friend. $generate is not. Okay. Forward zones, A for IPv4, quad A for IPv6. So, for example, a dual stack host might look like that. And in fact, that host is really my mail server. You can really talk to it if you are so inclined. Reverse PTR zones. As I said, $origin is very much your friend. Notice how I use that $origin to do most of the typing for the next 3 records. Otherwise, all 3 of those records would have to contain all of those digits. Not a lot of fun. Okay. Each entry contains 4 hex digits for the last quad. Note each nibble is a zone boundary. Why is $generate not your friend? Anybody want to take a stab at that? Sure. Have you ever seen all those hosts that are like 222.dhcp.pacbell.net and 223. Those usually come from $generate statements that say $generate 100 to 223 blah blah.pacbell.net, and then it creates DHCP 121 DHCP 122 DHCP 123 for you instead of having to type all those out into a zone file. You didn't think anybody actually typed all those numeric names into zone files, did you? So the reason $generate is not your friend in IPv6 is because if you try to $generate a /64, how much RAM do you have? How much disk space do you have? You're now trying to generate an in-memory database containing 18 quintillion entries, each of which is more than 64 bytes in length. So 64 bits times 64 bytes in length is bigger than most people's memory model. It's bigger than most people's disk space. It's bigger than some of the largest disk arrays ever built. Okay, who are we kidding? It's not going to work. You're going to run out of memory, and then you're going to have other bad things happen too. So in terms of troubleshooting IPv6, it's mostly like troubleshooting IPv4. Mostly the same kinds of things go wrong. Routers fail, routes get screwed up and point to the wrong destination. Trace routes look weird. Trace routes go in circles, et cetera, Just like in IPv4, start at layer 1 and work your way up. If you're using IPv4 and IPv6 together, it may be easier to troubleshoot layer 1 and layer 2 using IPv4 initially, because if it works for IPv4, it'll probably work for IPv6. Neighbor discovery is one of the places where things get very, very different. In IPv4, we used ARP, and everybody was kind of used to ARP sending out a broadcast packet and getting an ARP reply from everybody that thought that was their address, printing out the list of duplicates and moving on, right? It's different in IPv6. Number one, we don't have broadcast packets in IPv6. There are no more broadcasts, okay? Instead, we use what's called the solicited node multicast address, and we send the packet to the solicited node multicast address and see who answers. Other than that, it works very much like ARP. We send out the packet, the owner of the address replies, and we stick the reply in our neighbor cache. We call it neighbor discovery now instead of ARP. In IPv4, we'd say ARP and then the address. You could also say IP minus F inet, neighbor show, and then the IPv4 address. And in IPv6, that same syntax works for IP minus F inet 6. F stands for family, the address family inet or inet 6. Neighbor, show, and then the address. If you want to ping an IPv6 host, you need to say ping 6, and then the host name or number. Traceroute becomes traceroute 6, but telnet, SSH, and wget just work with the name or number as you would expect. You don't need special names for the applications. Finally, if you have an IPv4 only host and an IPv6 only host, and you want to communicate TCP between the two, if you can find a dual stack SSH server to stick in the middle, you can actually use an SSH tunnel to do the protocol translation for you. And you can review the slides later for all the details on how exactly to do that. I'm not going to read it to you. I do this a lot. I give this presentation a lot to businesses and whatnot, so we'll talk about staff training a little bit. Hopefully this presentation gave you some knowledge of IPv6. It's really a bare bones introduction. Before you start doing IPv6 at the enterprise level, you're going to need more training. Plan for it, budget for it, allocate time for it, and please don't bring your pagers and other noisemakers to the class. A word for management: this is not a networking problem. This is not an IT problem. This is an institution-wide issue. You need to plan on having everybody at every level of the enterprise involved in it. It will touch every single department from executive management to academics, IT, accounting, marketing, and even physical logistics and facilities. It is a major change to core infrastructure, and you're running out of time. If you're not in management, you need to be communicating these things to your management. With that, I will open it up to general questions. We have about 15 minutes left. Anybody? Yes?
Okay, that's better, I think. Nope. Hello?
Yeah, you're on.
Okay, great. Is it possible to use to declare some kind of template in Bind for RDNS declarations? That's pretty much because some email providers depend on RDNS to determine if a particular IP belongs to a dial-up network or not.
Well, more accurately, email providers depend on RDNS to determine that you belong to a dial-up pool.
Oh, yeah, actually.
And what's generally going to happen is that those email providers are going to recognize that you don't have RDNS if you're dial-up in IPv6 and move on. We are looking at ways to do on-the-fly generated RDNS records for IPv6 that's not presently built into Bind. And the problem with building it into Bind is the issue of, okay, but what happens when you turn on DNSSEC? You now need to have the ability to sign it on the fly, and if you're doing sign on the fly, then the DNS server has to have access to the private key at all times, and of course that's got security ramifications. So generate on the fly is probably going to happen. Generate on the fly with DNSSEC may happen, and it's still all up in the air, but there is work being done in that area. But as I said, $generate isn't going to cut it. Yes, I think there was somebody in the back actually first.
So we're out of IP version 4, and people still aren't changing over. Companies and ISPs still aren't changing over. Do you think there's a killer app that will drive adoption?
Yes. It's going to be called running out of routing table slots. When the IPv4 internet starts to implode from routing table growth, we will finally be in a rush to deploy IPv6, and it will happen relatively quickly. But the answer is, actually, ISPs are deploying IPv6. Content providers are deploying IPv6, not as quickly as I would like them to, but if you look at the growth graph in IPv6, we were at 0.01% less than 10 years ago. We were at 0.1% less than 2 years ago, and we're close to 2% now after crossing 1% just after last year. Okay? So around June of last year, we crossed the 1% threshold, and we're already up over 2% now. It is definitely arcing upward, and people are deploying it. And I'm trying to reach the people that are not, but it is actually happening.
So what's the best practice for organizations that have a large number of unmanaged switches with respect to RA Guard?
Replacement? I mean, you're going to either have to live with rogue RAs and you know, do what you need to do to cope with that being a possibility in your environment, or you're going to need to get switches that are capable of RA Guard. Yeah, what do you do about rogue DHCP servers and those switches? Well, it's an identical problem. Well, so you can, yes, but the rogue RAs that happen by themselves are set to medium or low priority, and so as long as you set your legitimate RAs to high priority, the rogue RAs should be visible but not problematic if they're accidental. But you still have the problem of malicious RAs. But the problem of malicious rogue RAs is exactly the same as the problem of malicious rogue DHCP. But unmanaged switches are an invitation to disaster in general. Yes?
How is that different from IPv4?
DNS conversion?
Correct. Like when we have the www.google.com, something like that.
You mean this? That's mailhost.delong.com. It's just shortened to mailhost because the zone name is delong.com.
Okay, so it won't make any difference.
No, you got an A record and a quad A record, and you're done.
Alright then. Other than that, I would question about the security, because I know at the beginning when people were talking about IPv6, they had a bit of a security concern.
I would say most of the security concerns in IPv6 are identical to v4, so I'm not sure. I mean, if you can ask me a specific question, I'm happy to answer it, but I can't speculate wildly on what you're getting at. Sorry.
I think some of the security issues with people thinking that v6 was a security problem were the same people that already had NAT for v4, and they thought, oh, our NAT is protecting us, and therefore with v6 we won't have NAT, and oh my gosh, we're going to be open. That's my feeling as to where v6 being security.
if you thought NAT was protecting your web server, I'm very confused. If you thought NAT was protecting your network, you're very confused. Yeah. So a brief thing on NAT in terms of security implications of NAT. Calling NAT a security mechanism is like trying to defend a castle by planting a lot of really tall weeds outside. It makes a great place for all the attackers to hide, but it really doesn't do anything to prevent them from coming to your walls. And when the weeds get thick enough, they can use them to climb over the walls. Any other questions? Yes? Time Warner says we're working on it, quote unquote. Hurricane Electric has been fully dual stack for more than 5 years now. So all of our POPs are full dual stack, and we offer native v6 as a production service right alongside v4. We're happy to support legacy v4 if you need that too. Different ISPs are moving at different rates. Verizon Wireless is, I believe, something on the order of 80% v6 deployed to their LTE network. T-Mobile has an opt-in v6 trial that they're running on their mobile phones at this point over 3 and 4G. Sprint doesn't know how to spell v6 yet. Comcast Business doesn't know how to spell v6 yet. Unfortunately, I'm a Comcast Business class user because it's the only form of broadband I can get in my neighborhood. But no, I don't keep track of all of the different ISPs. There's just too many of them. The best thing to do, by the way, if you're looking for v6 from your provider, is get v6 capable CPE, turn it on, see if it works, and if it doesn't, call them up their tech support line and ask them why not. And when they get through saying IPv what, and you get through escalating IPv what to somebody that knows what you mean and says, oh yeah, we don't do that. The next thing is, so when are you going to do that, or do I need to be looking for a different provider? It doesn't matter if you don't have a choice. They don't necessarily know you don't have a choice, and if they think that they're going to start losing business on it, that's going to be what's going to motivate them to actually deploy it. So make them think that not having V6 is going to be a reason for you to consider your alternatives. Yes?
You mentioned getting a IPv6 capable CPE. That's the DSL router or the cable modem, right?
Mm-hmm.
Have you dealt with which ones do you advise as to look into?
I don't give hardware advice. I will say I know that D-Link, Netgear, and even Linksys, though Linksys is the latest one to the party, all have IPv6 capable CPE. Having said that, if you can get away with using a straight layer 2 modem and something like a MikroTik for your routing, you're going to be far better off with the MikroTik. They have actually a very nice dual stack operating system, and they work quite well, and they're very, very cheap. I'm currently using a Juniper SRX100 as my primary router in my house, but that's talking to a J2340 in my colo, and I'm not your average household. I'm running BGP and taking a full IPv6 table and most of an IPv4 table at home. So, and I'm multi-homed across 2 ASs, and I have an autonomous system number at home as well. So, you apply to Aaron and pay $525, and they give you an autonomous system number, and then you pay $100 a year for it. Any other questions? Yes.
If you just, I don't know if this is off topic, but if you want a recommendation, I wind up using Viata software router on ancient Dell hardware. Runs on an x86, and it gives you a full BGP capable dual stacked router, and then you run that into just a straight DSL bridge.
And I will say, if you're looking for a very, very cheap router, you can stick a $7 Ethernet dongle from Amazon into the side of a $35 Raspberry Pi, load Quagga on it, and have a very nice router for $42. Well, actually, you need a 4 gig SD card, so $46 plus tax. Well, order it from Oregon. Any other questions? Okay, well, thank you very much. I've enjoyed this. Hopefully you have too.